Hello, my name is Darren Thomas, and I am the Director of Educational Research Techniques. This is Simpler, using machine learning algorithms in R. We're now in Unit 8, Chapter 8, if you will, and we're taking a look now at logistic regression. So we're going to have the same basic 4 lessons that we've been primarily following throughout this course. We're going to start with an overview of logistic regression. I'm going to try to give you an idea of kind of what's happening intuitively behind the scenes with it. And then, of course, we'll go into Lesson 2 with data preparation. Lesson 3 and 4 will be model development and model testing as normal. And so without wasting any further time, let's go ahead and take a look at exactly what's happening with logistic regression. Now, as I already mentioned, logistic regression is the classification algorithm. In other words, it predicts what category a sample would be in a data set. So if you're classifying by gender, if you're classifying race or whatever, it's able to do that. Now, unlike quadratic linear discriminant analysis or linear discriminant analysis, logistic regression is much better at handling fuzzy data. In other words, data where the separation between the groups is not so clear. And so we'll learn more about how that works when we get into the model development aspect of this particular unit. But there are several terms that I want to define for you before we move on, and that is probability, odds, and odds ratio. These are terms that I've always kind of struggled with when I've done logistic regression. And so I'm not, of course I don't know what your experience is, but these are things that I think might help you to better understand what's happening. So probability is simply the likelihood that a certain event will happen. So how likely it is someone will, live or die or be born a male or a female or whatever you want to pick, buy a Honda or a Toyota, whatever. That's what probability deals with. And there's a unique type of probability, very, very strongly supported and used throughout machine learning and statistics, called Bayesian. And so this uses prior probabilities to develop posterior probabilities based on new evidence. And so what happens is that as new data comes in, Bayesian probability is able to adjust the probabilities that they're making. And so one famous example that we've heard is that a few years ago, I believe this was 2016, during the Super Bowl, which is a famous sports event in America, one team, I believe it was the Atlanta Falcons, they had a 99.7% chance of winning at that particular moment based on the number of points they were ahead, based on the amount of time that was left in the game, etc. But despite this high probability, the opposing team, which I believe was the Patriots, was able to find a way to overcome these odds. And so what happened was that even though they had this tremendous advantage in terms of Bayesian probability, because it's updatable, it's subjective, and it moves, the Patriots were able to still overcome and eventually win. So, having said that, we know what probability is now. Let's take a closer look at what odds are. Odds are the expression of relative probabilities. And so right here we have the equation, if you don't mind. The probability of the event divided by 1 minus the probability of the event. So let's see if we can make this simple. The probability that the Falcons were going to win was 0.99 or 99.7%. Subtract 1 from this and you get a number of 332, which means that basically what's happening was that the Falcons were 332 times more likely to win the Super Bowl than the New England Patriots were at that particular moment. And again, odds are very commonly used in horse racing and all kind of gambling. This guy 5 to 1, 6 to 1, 4 to 3, whatever you want to call it, is very, very commonly used. And so this is important because often you can convert the results of a logistic regression model to odds and probability. It gets confusing, but it'll make more sense when we get there. Just trust me for a second. Now, the odds ratio is when you are comparing two different odds. Now, remember, odds can be represented as 5 to 1, 5 to 4, 4 to 3, but they can also still be represented as probabilities. And so if you look at the example here, we have 0.45, that's a probability, divided by 0.3, 1.28. What this is essentially meaning is that this first group is 1.2 times more likely to win or have the right outcome than the second group. And again, this can be very confusing, and sometimes it's not even clear for me. but it is critical that you understand that there is a slight difference between probability, odds, and odds ratio. Probabilities are the likelihood that a given event will happen. You can have the traditional frequencies probability or Bayesian probability. Odds ratios are the expression of relative probabilities, and they're often expressing, a number to 1 or 5 to 4, 6 to 3, whatever you want to call it. And the odds ratio is the comparison of two different odds. So before you can have an odds ratio, you must first have two odds. And before you can have odds, you must first have probabilities. I guess that's kind of how the chain works out there. And so, again, these terms will be very useful for you as you're trying to wrestle with logistic regression, because the output is slightly different. And you will see that when we get to that particular part in the model development and model testing stages of this unit. So in this chapter, in this lesson, I gave you an overview of what to expect in this particular unit on logistic regression. And we talked about several important terms: probability, odds, and odds ratios. These terms are critical to trying to appreciate and to interpret the results that will come your way from a logistic regression model. So I hope this was useful for you, and we're looking forward to seeing you in the next video. My name is Darren Thomas. I am the Director of Educational Research Techniques. This is Simpler, using machine learning algorithms in R. Take care.